Hello, I'm Heather Swope from Boson Protocol. My teammates are Ludovic Levallois, Ali Azam, and Gregor Barossa. Boson Protocol is building an open tokenized economy for decentralized commerce focused on trust-minimized transactions. Boson Protocol uses NFTs encoded with game theory to allow digital to physical redemptions. A seller creates an offer that is represented by a voucher set implementing the ERC 1155 standard, where the balance matches the available supply of the items for sale. Each time a buyer commits to the offer, an ERC 1155 is burnt and a more classical ERC 721 is minted and transferred to the buyer's account. The ERC 721 represents the committed voucher. The biggest problem that everyone knows about Ethereum is that the gas costs have skyrocketed. This could be a barrier to enter the e-commerce world for buyers and sellers. We'd like to make it easier for sellers and buyers to interact with the protocol in a gas-efficient manner. We want to allow sellers to make an offer, that is, create a voucher set, directly on multiple L2 chains. If the seller has a quantity of 10 items, he could say, I want to sell 5 on Polygon and another 5 on Arbitrum. In that way, the buyers can actually choose on which L2 chain they want to buy. The reason they would do this is because some people are more familiar with one L2 chain than another. They might be more comfortable using Polygon or Arbitrum, depending on their experience, or depending on which chain they own tokens to pay the gas. The problem is that if there are more purchases on one L2 chain than the other, it would lead to reduced supply quantity on one chain and a high supply quantity on the other, and vice versa. So, the protocol should offer a mechanism to balance the available supply of items between the chains, depending on the demand. That's what we have built for the hackathon. The solution is using two L2 chains, Polygon Mumbai and Arbitrum Testnet, where we have deployed the Boson Protocol contracts. In order to interconnect these two chains, we have deployed Chainlink nodes, one on each chain, each coupled with a Chainlink external initiator.
For the purpose of the demo, the Arbitrum chain has been replaced with the Gurley testnet because we had a few problems when transacting on Arbitrum that could not be fixed on time. So we have the Boson protocol deployed on two chains, Polygon and Gurley. A seller has created an offer on both chains with a quantity of 5 on each, and 3 buyers have already committed a voucher using Polygon so that the available quantity on Polygon is now 2, whereas 5 remain on Gurley. Now a buyer will buy one item again on Polygon. The supply quantity on Polygon is now only 1 and the availability on the other chain is still high. Then the balancing mechanism is happening. Here are the events raised by the local Oracle contract on Mumbai. The last one raises the Help Me event that triggers the jobs on the Chainlink node connected to Gurley. On the Chainlink node interface, we see the job activation triggered by the event raised by the local Oracle contract. Going back to the contract's events, we see this new one raised after the Chainlink node on Mumbai has called the contract to notify it can increase the supply quantity of the item for sale by a value of 3. In the end, the available quantity on Polygon is moved from 1 to 4 and the one on Gurley from 5 to 2. As a conclusion, our balancing mechanism moves the supply quantity to the chain that has more demand, without compromising strict inventory management at global level. This hackathon has been a rich opportunity for the team to learn more about the L2 chains. Thank you for your attention.